Good morning, everyone. I'm Nirajan from Fitchburg State University. I'm collaborating with my colleagues Nipesh and Kishor Shrestha for this research. And we are in the preliminary stage of this research. The topic of this research topic is leveraging large language models to enhance safety, awareness, and accessibility of OSHA regulation for construction workers. As all of you know that construction industry is one of the most hazardous industry globally, and we are facing significant challenges ensuring worker safety and regulatory compliances. And the traditional manual methods have a lot of issues, like this time consuming to review the construction policy, regulatory documents, and there is inconsistency, biases, poor data integration, and limited adoption of automation. And the big challenge is also scalability issues in traditional method. So with the advancement of automation, artificial intelligence, machine learning, and natural language processing that offer transformative opportunity to streamline document review. And with this technology, there is a potential to revolutionize the construction industry by automating the review of those policy or regulatory documents and extract the required or actionable insights from those documents, so that the stakeholders will have data-driven recommendations. They don't have to go through all detailed informations. They can just get what they need during their work. And also, this study explores a novel approach to leverage LLMs to enhance access to construction policy and regulatory documents. And the main objective of this research is to improve construction site safety by utilizing LLMs trained on OSHA regulation to process images, files, and textual reports that enables them to identify safety hazards, mapping them to relevant OSHA regulations, and generate actionable mitigation recommendations, and analyze the multimodal construction safety informations, including texts, images, and reports. And it also contributes to the growing body of literature on digital transformation in construction safety and management process. So when we started this research, our first vision is how to simplify the review process, the regulatory documents, OSHA regulations. They are huge files, and it's really time consuming. So how can we automate that review process so that construction workers will get actual like safety instructions, safety regulations, whatever they have like work on site, so they will be pre-informed. Because currently what we have is we provide the training to the construction workers, but all the they cannot retain those information in their mind during the traditional training process. So if we can give what they need, actual piece of like informations, that will be helpful, and they will understand those things. So as per our research, it shows that there is a lack of understanding of safety protocols that contribute mostly in workplace accidents. Also, the workers often fail to retain information they learn during their conventional training process. And also, there is a diverse workforce, and some of them, they don't have a they are different language barriers they have right now. So some of them are non-native English speakers, and the documents mostly written in the English or other languages that they are not aware of that. And those scenario demands more accessible and inclusive solutions to enhance regulatory awareness among workers and employers. And the LLM, this AI applications have some potential to mitigate those kind of challenges currently we are facing. There are some other research conducted in different sectors like finances, government administration, or legal and business sectors. These are already implemented. Some other research show that, for example, the Pu et al. Proposed a multimodal large language model framework to automate the generation of construction inspection reports, meeting regulatory standards and reducing resource waste. Chantal et al. Also investigated the impact of integrating real-time feedback system with LLMs on workplace safety. LCL and and Fantis analyzed the role of Vision Zero within the EU strategy framework on health and safety at work and its alignment with the Sustainable Development Goals. Lee et al. Explore how LLMs can enhance BEAM workforce, focusing on speech-to-BEAM system within their proposed generalized LLM augmented BEAM framework. So this is a simple research framework that we just designed. Like first, we review the literatures, review the OSHA regulation and other regulated regulation documents. Then LLM train on OSHA regulations, organizational safety guidelines and best practices, and the annotated safety reports. For this research, we just focus on giving some input like image files and text inputs. And then for mapping, for each identify safety hazards and model queries is knowledge-based and retrieves the most relevant OSHA standards. We follow the semantic similarity matching process, extraction of appropriate regulations number for that specific case, and plain text explanation process. So as this is in preliminary stage, so we just took a couple of images that is already existing, and we feed that images in customized ChatGPT version with some prompt we use here, and we try to get what this customized ChatGPT will provide, and we try to validate those information. So as most of you already knew about this pictures, this is a very popular images. Here 11 iron workers sitting on a steel beam on September 20, 1932 during the construction of the Rockefeller Center in New York. And although this work was done before OSHA was established, but can you identify some safety hazards by just seeing these images? If you have some safety knowledge, you can identify some of them. And what we tried is we fed this image into this customized ChatGPT and use this prompt there. We try to identify the potential safety hazards from these images or reports we have other, and create a table with a list of hazards along with their corresponding regulation number, short description of each regulations, and ask a few recommendations to mitigate that hazards. And what we got, this is the results that we got. That we have a safety hazards, list of safety hazards with the relevant OSHA regulations numbers we have here, and with the short descriptions about those safety hazards. So for that image, there is a lack of fall protections, workers seated on narrow beam with no secure footing, no visible personal fall arrest system, overhead, work without protections from falling objects, lack of proper access to the work area, workers eating and relaxing on a high elevation surface, and no fall protections training for workers. So those are assumed from the image here. So out of 3 colleagues, 2 of them have authorized OSHA trainers. So they reviewed whatever the outcomes they come from this customized GPT versions, and they verified. Since this is just a very preliminary stage, we just did a couple of experiment, like a couple of tested here, but we are envisioning to further expand this research and form a committee, a safety committee, inviting like experts from the OSHA, local OSHA officers, and also some experts, academic and industry experts, and validate those results from the analysis. And these are the recommendations that we got to mitigate the hazards of like implement fall protection system, provide proper training, use stable platform for brakes, protect against falling objects, and use proper access the systems. This is the second examples, like improper storing in a trench, and these are the preliminary results we got for that images. And these are some recommendations that we got to mitigate the hazards. So although this is in initial stage right now, we are reviewing existing like different hazard scenario right now. And once we have analyzed all those detailed informations, then as I just mentioned, like we'll be getting feedback from experts, and then this can be used also for monitoring system in future, because like on site, like safety inspector go, visit our site, and they see they evaluate the work, whether the site is safe or not. They give the feedback. But before getting inspectors feedback, the site supervisors can also visit the site. If the system is advanced, if you can advance, then they can take pictures, they can put it that's in the system, and they can get initial feedback whether the site is safe or not from the system. So that's our envision. We are working on developing that platform. Currently, there are various limitations in this because there is a potential limitation of current LLMs, including confidentiality and privacy issues. And although the model is trained in OSHA regulations, it might return fictional responses when appropriate OSHA regulations are not found in the system, and the fine-tuning necessary for specific use cases. The statistical validation is critical because the study focuses on the safety and health of individuals, and consequences of inaccurate responses can be life-threatening. With the rapid development in reasoning models, with the advancement in this LLMs and this AI system, the accuracy and reliability can be improvised, and like we just envision we can use that for monitoring system in future also, so it will open some new door for further research. In conclusion, like the use of LLMs offers groundbreaking approach to improve safety awareness and access to OSHA regulations for construction workers. It also enhances construction site safety by utilizing LLMs trained on OSHA regulations. The models can be processed through image or textual form reports from a construction site to identify hazards, align them with relevant OSHA regulations and guidelines, and generate actionable recommendation for risk mitigation. It also enables workers to quickly understand safety regulations, recognize potential hazards, and implement compliance measures without requiring extensive regulatory training. And it also supports on-site job hazard analysis process. So thank you once again for this opportunity.